Hello friends, welcome to this new video. In previous video, we have seen that how we can download the image and explore it in Envi, right? So in this video, I will explain how we can make Composite. So let us first understand what is Composite, right? So in last video, we have seen that in image folder we have different band files, right? So these are individual band files and contain the reflectance of a range in a spectrum. Let me show you that ranges. So friends, here you can see that band 1 contains 0.43 to 0.45 micrometers and so on, and up to 12.51 micrometers. And here we get 10 and 11. These are total bands in the resolution of 100 meters, whereas cirrus band is 30 meters, whereas panchromatic is the final resolution that is possible in this Landsat image, which is 15 meters. Right, so sometimes we use this panchromatic image to remove the strips in the image. It can be used for correction basically, right? So in the individual bands, we can see that we have data from a range of spectrum, but if we want to merge these ranges, we need to stack one over the another. So what we do is we stack one image over the another and we try to make it a composite like whatever we see in the real world. Like in real world, we can see red, green, blue combinations. These are the primary colors, and with the help of these colors, um, even all the pictures can be made. All the colors can be made. All the color combination can be made basically. So every color combination has its own importance, and multiple features can be identified using multiple composites. So composite can be basically of two types. One is true color composite and false color composite. Right. So true color composite is what basically we see in real life. That is RGB. So red and blue can be combined to create any color, any sets of color. So RGB, whenever these three band two, three, and four are merged, basically in reverse order, four, three, and two makes RGB. The two band combination is known as our true color composite, whereas false color composite is the composite made of color combination and using some another color in place of this RGBs. Like if you want to put this band 5 in place of this blue, then it will be a false color composite. Right? So let us understand this by print. So suppose we have one image. Okay. Hmm. Another image over it and some another image over it. Right. And suppose these all images belong to separate bands, and these all are georeferenced, basically, which means they all have same reference data, spatial reference. They have the same latitude and longitude data. Now, uh, suppose it has some DN number, image one has some DN number, and there's another image has some DN number. So when they are overlapped, as a result of this overlap, some combination comes which we call a composite, right? So our composite will contain a data which will be a combination of all the DN number that are in stack, right? So this will contain a combination. So it will appear differently as that of that individual band because and it depends on the combination. If you use RGB, then it will be a SID, a DN number using red, green, blue combination, right? Or apparently it can appear differently from RGB when we use some other combinations like for agricultural purposes. The combination of 652 is very much used. Let us see some of the combination of false color composite. Let us open this Composite website. So here what I have told you is natural and false color composite. So when we make natural composites, basically it comes in the form of RGB, which we call true color or natural color composite. Whereas in case of false color composite, we allowed some another component to in place of RGB, right? So there are band combination, multiple band combinations are there. Like for natural color, we have discussed 432 is RGB. For false color, urban settlements can be better observed in this combination 764 for agriculture. It is 652 for SWI 754. These are different kind of combination. You can make your own. Right here, this is a very interactive website, and they have given a link to create basically different color combinations. So you can just visit. It's the website of Composite. I'm also bookmarking it. It can be a great lesson. Right. So this is what basically we are trying to create. So we have different images, right? We have different band images, and we will combine them in various combination to create one composite image. Right. So now let us move to the Envi. Let us create the combination, right? Okay. So here I am just dragging, simply dragging the image. V7, then we have B10, right? We have B10 as thermal band. So I'm dragging it in the Envi. All the images have been loaded. Now I'm zooming them to full extent, right? Now let us make them invisible. You can see all the individual bands look different because they have different reflectance value. Because all the features and reflectance is different in different band of spectrum, right? So for making the composite, we have a tool named layer stacking in this Envi. So here you can type layer stacking. So the tool will simply appear here. or otherwise you can just go to raster management and select this layer stacking tool. And kindly note that when you click on any tool, it will show the complete address of that tool inside the toolbar. So here it is raster management, and inside it layer stacking is there. So when you search it, it will also show the same. Now, see, when I search the full name, it's showing me the path. So just simply click on this layer stacking, and here we have to import my image. So for composite, I'm using 4, 3, and 2. Basically RGB, I'm creating a two-color composite. We have option to select the spatial subset. Right? If we want the full image, then we can continue with full image. Right now, I'm continuing with full image and canceling this spatial subset. Just click on OK. So these images have been imported, right? So we have 4, 3, and 2. Now, here is the output result option. If we want to output the image into a file, we need to select the file. Otherwise, we can import it, uh, create output to memory in RAM, and whenever we will close the software, it will be deleted from the RAM. So it is better to save the file in our memory. So just choose the path from here. Here I am saving it in downloads and giving it a name composite.tif. Remember friends, this TIFF is important because TIFF is the format for tagged images, right? So do not forget to give the .tif extension at the end. Just click on OK. Now the path is given, and at the right we have option to change the projections. But you can change it as per your convenience, or otherwise let it be as it is. We can change the units to meters and kilometers. So our original measure is in meters, right? It's 30-meter resolution. So we have 30 cross 30 width. So let it be in meters. Or we can change the pixel size. If we have 30 cross 30, then we can either downscale or upscale from here. That's it. And this is resampling. We have options to resample. You can see. And with this, we can move forward. Just click on OK. Let me start creating the composite basically. Now it is creating the composite image. So here is our composite image. It looks like this. And these tiles are being processed. So here is our entire image. We can zoom it. You can see how it looks like in RGB basically. Resolution is not very fine. That is why when you zoom it, it starts becoming blur. You won't be able to see the pixels, entire pixel basically. But this is how an image looks like in RGB. So you can see the settlements can be observed in this brownish shade, whereas this barren land soil as it is like whatever it look in the real world, it is looking in the image because we have created the RGB composite, right? Now let us try to create a composite. Let's false color composite. Suppose we want to identify healthy vegetation. So we would look for the 562 bands. So let us create this one. Again, we will go to pair stacking, and to open a file, and we will select here 5, 6, and 2. 5, 6, and 2. This time I'm going to create the composite of a spatial subset basically. Spatial subset meaning a small area from our entire image. So for this, we have separate options like ROI, AVF, and this is Envi vector file basically. Generally we use zip files, but we are going to create an image. So we will need to drag this from the edge and then move it like this. So right now I'm selecting this red area. Just click on OK now. Click OK. I am saving it with the file name vegetation. Notice the path is given. Now let us select the unit. Let it be in meters. Now let us try to change this to 20 meters. We are trying to downscale basically. Let us see what it does. And let us choose cubic convolution. Okay. Basically, convolution is a method of uh, convolving an image. Right. So basically, in convolution, two functions are overlapped and shifted. One is overlapped, flipped, and shifted over the another. In this case, a kernel is created and uh, it is shifted over in the entire image to detect the edges and boundaries of features. So this is how our image looks like. Let us zoom it to full extent. Now, this is showing like this because we have a spatial subset. So friends, you can see that vegetations are well observed. We can read the description how to see. See where it wrote that healthy vegetation appear bright red and they reflect more near infrared than green. So let us look for the bright red, meaning this portion have very healthy vegetation. Basically, this looks like the river part, so here they get more nutrition. or let us search for this combination, get more details about it. Okay, so in a 562 image, healthy vegetation appears shades of red, orange, yellow, and brown, while soil appears brown. Other features such as clouds and ice appears sun blue. So for a well vegetation, we will have to look at this red, orange, yellowish, brown zone. So these are the regions having rich vegetation basically. So this way we create the composite and we can try to analyze different features. We can get details of it. It's you can create your own composite. Now in next video I will be showing some other tools. So keep connected and follow me, subscribe my channel. Thank you.